Industry is shrinking, and therefore the work that I've been doing is a little bit about trying to hold on to the bell industry, redefine bells, and maybe find bells a place in contemporary urban design. So that's a suggestion that I'm trying to make today. I did want to talk a little bit about the craft traditions. You often think of them independently or as a sort of past historical, social existence. Craft is really built into the heart of what a community is, and it has a responsibility to stay connected, not to become stranded. I think the saddest thing is when craft becomes a tourist output for a community where people come and see the craft that was. I think we have so many challenges coming to us as a planet. This is a time when craft needs to be at the very centre of creativity in their communities to find innovative solutions, and that's what I'm trying to do with bells, one of the most arcane crafts that you can imagine. My own training began in a sculpture foundry in the early 1980s. That's the person in the red shirt is me pouring sculptural bronzes, and so yes, I did my training as a foundry person, casting bronze for sculptors. I started teaching at the Victorian College of the Arts, and my sculptural work just slowly moved towards bell-like shapes. And so on the very left over there, you'll see the first bell that I made, which was a handmade sculpture, and it looked like a bell, and I decided to put a clapper in it. And then from that, making that, I got a commission to make a little set of bells, and to make, which is the middle picture, and to make that, I worked with a colleague at Melbourne University using finite element analysis to see what was possible with the design of a bell for its sound. And that was taken from Eisbut's Bell Foundry and Eindhoven University of Technology, who in the 1980s worked together to try and change the sound of European bells. And so their work was inspirational to what we thought we could do. And the three bells are computer modelled bells, handmade from the computer printout. And while they're very crudely made, what was surprising was how close the actual bells were to the predictions the computer program made. And so that opened up the possibility of, wow, if we could trust the computer program to be close in terms of the sound, why don't we explore what's possible? And so I started a PhD in order to do research into bell design using finite element analysis. The third picture is the Federation Bells, which is in Melbourne, and that's a fantastic commission that my company Australian Bell was given. And over 4 years, we researched bells. We built a harmonic bell carillon in Melbourne and did several other bell projects using computers to design a harmonic bell, which I'll show you and let you listen to, and resolve a harmonic bell, which is the most perfect sound bell. So the world's most perfect musical bell. I don't know if there are carillons in the Philippines, but there are carillons all over the world made up of church bells. And the church bell is particularly not a very good musical instrument for carillons. They're great for churches, not great for musical instruments. And so I've spent all the years since the 2000s trying to persuade the world to let me build the most perfect musical carillon. And that's been a very difficult task. But that's the installation in Melbourne where there was a performance of people on flexible posts playing manually the bells. So after the Federation Bells projects, I started just exploring the possibilities of using digital technology. The first obvious one was 3D printing. So this is a 3D printed bell. The bell itself is a harmonic bell, so it's created entirely, it's an artifact entirely from finite element analysis software. And then in the virtual space, the bell's created, 3D printed, put into resin sand, taken as a pattern, as a foundry pattern, taken out. In the vacant space left behind, bronze is poured in, and lo and behold, you get yourself a harmonic bell.
Which sounds like this. So the beauty of this bell, can you hear me without that thing?
Yes.
Okay, this may be better for me as well. The beauty of this bell is that it has a single pitch. It only has one note. And even though that's kind of boring if you listen to it next to a European church bell, which has two notes, as polytonal, for musical purposes, this bell is just like a piano. Okay, so, and you can see, optimized by a computer, this bell was cut on a CNC lathe, so no hands are involved in its production, and a little miracle of the digital age in terms of bells. I'll have to use this, I don't know. So from that technology, you know, and using CNC lathes to machine bells, you start to get some truly accurately made objects where the computer has generated a profile to give you an extraordinary sound. So I got into 3D modeling bells, then 3D printing bells, and using the 3D models and CNC lathes. But you can see the old process of using resin sand and a strickle. But in this case, the strickle's laser cut because of using the computer shape, and then made in resin sand. And in 2013, Brian Eno became aware of the work on bell design that I was doing, and he introduced me to the Long Now Foundation. Now, I don't know if any of you know about the 10,000-year clock. Seemingly not. But if you were to Google 10,000-year clock later on, you'll be absolutely amazed at this project that's happening in West Texas. So Jeff Bezos has put $42 million into building a clock that is inside a mountain, and this clock is an engineering marvel. And it's designed to operate for 10,000 years, the next 10,000 years, whether human beings are alive or not. And if you look up the Long Now Foundation's philosophy, they want communities to think about making long-term decisions, not short-term decisions. That the planet requires us to now think in millennium scale, not the political scale of 3 or 4 or 5 years. And so they're doing quite a lot of research projects, but the clock is the big celebration, big signal about what the planet should be thinking about. If you look it up, you'll be totally amazed by the engineering of it. And so I was incredibly lucky to be invited to invent the bell, the 10 bells that will go inside now the clock. So their main problem was they drilled out the inside of the mountain, so there wasn't, and of course the clock mechanism is 200 feet tall of stainless steel wheels, and even though it looks like an analog clock, it's a digital clock, and there wasn't much room to put the bells. But Brian Eno, and they showed me a video of him standing on top of this big hole in this mountain in West Texas and going boo, 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 trying to get the resonant frequency of that space to work out the musical scale of the bells required for the clock. And so he worked out a musical scale with the lowest note being C65 hertz, which is at the very low end of a piano scale, very low note. And a normal European bell for that that pitch would be 2.5 tons, and just too big to fit inside the mountain. And so they wanted to know, was it possible to use difference tones to make a bell that would generate that note but only be half the scale. So in the past, or currently, organs, for example, if you need a C65 note, you need a 64-foot long organ pipe. Very few organs have that sort of capacity. So most organs have 32-foot pipes, and they play that pipe in its perfect fifth at the same time, and it generates a psychoacoustic note in the ear of the audience, an octave below the 32-foot pipe. And it suggests to the audience the C65, 64-foot organ pipe. They wanted to know, was that possible with the bell? Well, working with engineers and using finite element analysis, we asked the computer to see if it could resolve this, and it resolved a shape, and the shape is this shape. And so this is the world's first only difference tone bell. So it's a bell that generates the frequency that you hear doesn't exist in the bell. It exists in your ear. The bell is an octave higher. All of its frequencies begin an octave higher. So we all jumped for joy when finally this bell was invented. It suited the purposes of the 10,000-year clock, but it also it opens up a whole new way of thinking about what sound might be for bells. So after a research period to find out if it was possible, I was invited to make the 10 bells for the clock mechanism. You can see how large the biggest one is. That's me standing next to it there. That's 500 kilograms, and that's the one that generates the C65 hertz pitch. So this is the making the bells and the bells being installed. So you can see the pictures on the top. You can sort of see that's the hole in the mountain that they've drilled out, and it's a picture of my little bells being held in there when I cast the first ones, and they took them up to the mountain, put them inside to see if the resonance worked with the space, with that hole. And then you can see them being installed. They're installed now, and they're being tested currently. So you can see inside the mountain the two pictures of two of the bells being installed in the 10,000-year clock. Now I know. I know you don't know about the 10,000-year clock, but you will come to know about the 10,000-year clock because it is that amazing. And there are some people, some Americans, who think, what a waste of money. It could have been used for other things. As Xander Rose, the CEO of the project, says, it costs the same as making a Hollywood movie, $42 million. But it will stand for a very long time as a symbol of what humanity should be thinking about, like the pyramids stand now for us when we look back. So up until very recently, I wasn't allowed to talk about the clock at all. And I got permission, because I said I was coming here, to show you some pictures of the making of the clock, because I thought that you might find it a little bit interesting. But also because I've been having discussions with Joseph about the notion of the handmade versus the industrial. These clocks, this bell is a computer artifact. But the making of them at large scale still requires one to work. So that's the core of the bell. This is the mold sections for the outside of the bell. Then they're put together, and there's a negative space where liquid metal is molten metal is poured in to make the bell. If you go out, and then the bell comes to my studio, and then there are about a month of me quietly grinding by hand around the bell, taking fractions of metal off, tuning the bell. Because when you pour cast metal into a mold, it never has the same porosity. It's never exactly the same. It's all so. When you get the bell, you'd like it to be. It's close to being in tune, but it's not in tune, and it takes quite a lot of physical, manual work to tune the bell. And I put these pictures in to give you an idea that the slow process of making and tuning the bell. And this part of the bell, this part of every one of the 10,000 year bells, I've left alone. I've left the casting surface on. And so if you ever do go to West Texas and you climb the mountain and you go up and see the 10,000 year clock, you alone will go, hang on, that little ring, that's the original casting surface, not being touched. And you'll know why that's the case. And the reason why I left that little section was to let everybody in the future know that a human being made this, and this thing was through a process of risk and difficulty, and one had to overcome the problems of casting discrepancy. And so that's a sort of part of leaving behind the sense of the handmade in the object. When I finished that project, which was in 2017, I was lucky enough to get an opportunity to have a residency at the CSIRO, which is the scientific research organisation in Australia. They've got a section called Lab 22, where they do 3D printing in direct metal. And so I spent 3 months working with them on 3D printing in titanium, the difference tone bell. So I brought some along here. The biggest ones are in exhibition in a museum in Melbourne. So I couldn't bring that. So I can only bring in this small first titanium difference tone bell. So this is 3D printed in titanium. It's a bit small, so not so great for you to hear. Now it's so high, that pitch, that you can't really tell, but the actual pitch of the actual bell is an octave higher than what you're hearing. So it actually sounds like a bigger bell, a bell double its size. And that's in titanium. There's a company in America called X1 that they've got a very interesting 3D printing in metal process. What they do is they and I get to show you a little bit on the next slide, I think. They have a box of stainless steel powder. And if you imagine an arm goes across the top, and then they print a layer with resin, and then they have multiple prints of those layers, and then in the end, when you've got this very delicate stainless steel held together by resin or glue, and then they put it in a kiln with aluminium oxide to hold it in place, and they pour in bronze tin powder, take it up to 1100 degrees, and the resin's driven out, and the bronze tin runs in and replaces it, and so you get a composite material. This is 316 stainless steel with tin bronze. And this is where you'll hear a difference tone. I don't. In bronze, it's a little bit clearer, but when you hear a difference tone bell, you hear kind of two notes that evoke in your ear the pitch, and the pitch being that octave below. Anyway, these will be here for people to play with later on. So these are the world's first 3D printed metal bells. And it's clear that that in the future, as the price comes down and the scale of printing goes up, it will it will benefit no one to cast in traditional ways bells, because the consistent density, the profile control of 3D printing is so exact that the musical possibilities are widely opened up. And the crudity of casting and then hand finishing bells is then left into the past. This is for very sophisticated musical purposes. So it's a kind of gateway into a new way that bells might be thought about. So this is a little demonstration of how the 3D printing works. And that's a laser. So each layer is fused with a laser, and then the frame drops down, and another layer is fused, and another layer is fused, and in the end you get your object that's 3D printed. So so this is a work that I created last year, and it's installed in Melbourne. It's a 3 meter tall twist bronze bell. So using computers to design new musical bells also opens up the opportunity of using computers to play with shapes in order to get new aesthetic forms and interesting sounds. So this is on a central post. It just floats above the ground. People go by, they hit it with their hands, and there's a beautiful resonance from this beautiful shaped bronze bell. And I'm hoping more and more of these beautiful bells will exist around the place. So the ancient craft of bell making, integral to religious communities and old communities, has lost its way. And the foundries are closing, the demand for church bells is falling. How does the bell stay vibrant in our future? And my argument is new urban designers, contemporary urban designers, need to be thinking about acoustic overlays on the sort of social habitats that they're designing for the future. And in the past, where the old poem in London, oranges and lemons, the bells of St. Clement's, you could by your ear navigate your way through London by the difference in the sounds of all the bell installations. Those bells have been either taken down or unified so that you can't tell the difference between the bells in one part of London or another part. And placemaking and wayfaring ought to be really powerful tools for contemporary urban designers thinking about acoustic overlays. Acoustic concerns for urban designers shouldn't be just about noise reduction. It should be about the sort of social experience that's possible by controlling acoustic arrays in social space. So the work that I'm doing is trying to, because I mostly write proposals for public space artworks, is trying to get councils to think about the kind of acoustic experience that can excite their community and bring their community together. The installation of the Federation bells in Melbourne, you can go to www.federationbells.com.au. You can download a phone app and just idly drinking a cup of tea, you can compose using those bells and email that composition off to the curator in Melbourne, and they'll send you an email saying when your composition will be played on the bells. You've got to get in an aeroplane, you've got to fly there, you've got to be there. But you take your chicken and your champagne, and even though it's raining, your composition's played on the bells, and in the end you stand up and bow to the seagulls that also enjoy your composition. But I recommend that you go to federationbells.com.au, that you think about downloading that app, because it's just fun composing with the bells. And I recommend you go to longnow.org. I think it's really to your advantage to have a look at what the Long Now Foundation research projects are, but definitely look at the 10,000 year clock and get blown away by the technological brilliance of Danny Hillis and Brian Eno and the team that have brought you the clock. And I'm just being in the world a playful explorer of digital possibilities for bells. It may be not of great consequence. I think it's though part of the pathway that craft stays relevant and connected to its community and becomes still part of the economic machinery of a society, not reduced to a tourist stand alone, sad memory of that community. And so for me, digital tools aren't just a way to replicate what already exists. They're a way to bring craft making back to the center of what a community's well-being is all about. And so I think I've got one more slide. So, and just to finish up, I was telling Joseph I was a bit loath to come here because I've been engrossed in making my own clock. And I've been playing with 3D modeling and working out cogs and finding out all the mistakes I've made by laser cutting, and then, oh, that doesn't work, laser cutting. The joy of trying to figure out how a clock works and to make one work, and I feel so close to it, and I don't want to get sick and die, and have my clock not actually working. But that's my studio, full of bells and full of a beautiful little clock that I want to bring to life. And so if I can get across to you the sense that the joyfulness of a life lived in digital exploration, I will have done something useful to and contributed to your thinking about how good life can be and should be. Thank you very much.